Hey everybody, Mr. Morel here, and we're going to talk about the distance formula. I think it probably seems like we're jumping all over. At first we're talking about areas, which was a measure of the inside of a shape. Then we were talking about the lengths of the sides of triangles. So, it's kind of weird. We went from area inside to lengths on the outside, and all of a sudden we're talking about the distance formula, which is between 2 points that seemingly has nothing to do with shapes. But I always have a method to the madness, and the distance formula relies heavily on the Pythagorean theorem. If you want to find the distance between 2 points, then we're going to need the Pythagorean theorem to help us out there. And the reason is this. If you see these 2 points, like look at question 1. We've got a point here and a point here. If I wanted to know the distance between these 2 points, well, even if I draw a line there, I can't really tell you how long that line is. I mean, maybe you can give me a kind of estimate, but I don't know. Depending on your estimating skills, maybe you're really bad at that. I don't know. So, something cool that we could do is some of you kind of see these points on this grid and you can start to visualize a triangle like this, which is great because the length of this side of the triangle is the same as the distance between these 2 points. In other words, if you can find this length here, if you can find the length of that triangle, that will tell you the distance between the 2 points. So in question 1, it's not asking us, I don't need you to find the distance of the points yet. It just says, just sketch the triangles that will help us later. So I'm going to do that. And I'm going to keep using red and blue just because that helps, I think, some students see the 2 legs and then the hypotenuse of these triangles. And so I'll just keep doing that. If you don't like it, oh well. But yeah, take a look at those triangles that I just drew. Those triangles are totally going to help us find the areas. I also want to point out that you could draw your triangles in a different way. Maybe you want to draw your triangle like that. I have no problem with that. The dimensions of your triangle will still be the same. Alright, let's head down to question 4 and get to work. So, question 4 wants us to find the distance between these 2 points. And it wants us to write the distance both as an exact distance and with a square root. Now notice, I'm actually going to be modifying this. I said this in the last video too. I'm going to modify this so that it says the distance equals blank, which is approximately blank. Because I do want us to be specific and have exact answers using square roots. But I also think that's kind of hard for some of you to conceptualize how far, like, the square root of 2 is. So it's helpful to give an estimate just so you can get a good idea. Okay, so why don't I go ahead and just draw in a triangle here. And if you're playing along at home, this is pretty easy. You can count how long these sides are. For example, this side is 3, and this side down here is 4. And I'm not counting like lines in between. I'm counting like side lengths of these squares. So here's a side length of 1, 2, and 3. Here's a side length of 1, 2, 3, 4. Now I can use the Pythagorean theorem. Let's call 4a, let's call 3b, and let's call the distance we're trying to find c. So the Pythagorean theorem says that a squared plus b squared equals c squared. And so we can plug in our numbers. 4 squared plus 3 squared is going to equal c squared. We're still trying to find c. So that means that 16 squared plus, 16, because 4 squared is 16, plus, oh my gosh, I am making a mess. 16 plus 9 equals c squared. Well, 16 plus 9 is just 25, and so that equals c squared. Now the answer is not 25. Imagine, this side length here is only 4, and this side length is 3. I don't think that it's possible for this whole distance to be 25. But remember, we now take the square root of both sides to get c by itself. And the square root of 25 is 5. So that is the distance between the 2 points here. We just found out that this exact distance is 5. All right, let's come over here and do question 6. Question 6 is a little bit trickier. It's not such a clean answer. Okay. Drawing my triangle like that. So let's count the sides. It looks like we've got 1, 2, 3, 4, 5, 6, 7. A side length of 7 here. And with my eyeballs, I'm counting a 4 there. Let's call 7A and call 4B, and we're trying to find C. Using the Pythagorean Theorem, 7 squared plus 4 squared equals C squared. So 49 plus 16 equals C squared. Well, let me just double check. 49 plus 16 in my calculator is 65. Now remember, this side length here, that is not 65. The side length is going to be the square root of 65. So if I type the square root of 65 in my calculator, I get a crazy decimal. So I'm going to want both an exact answer, so the square root of 65, which is approximately, looks like 8.06. And I think that seems a lot more reasonable. If this side length is 7, it makes sense that this one is just a little bit more, and it's almost 1 unit longer. Alright, let's go on to the next page. Oh, dang it. Morel! What a fool. I took out the grid lines. So we can't just rely on counting anymore. We're going to have to do something else, something different. I mean, you can draw a triangle, that's not any problem here. But figuring out exactly how tall this is and how wide that is going to take a little bit more work. So, let's start by figuring out how long this is. Well, remember, the y parts in our ordered pairs tell us how far up and down each dot is. So if I knew the difference between my two y values, that should tell me how far up and down this red line is right here. So something I could do is I could take 5, this 5 right here, minus 1, and that's going to give me a side length of 4. And if I'm going to use a different color, if I wanted to figure out how far over these dots are, well, that's going to relate to our x values here. So I could take negative 1 minus negative 5 and find out that this is a side length of 4 as well. Now, that's going to be really hard for some students to conceptualize, but we've done this before with slope. You just haven't connected it yet, some of you. I could actually make a table and plug my ordered pairs into this table. In either order, it really doesn't matter. And if I want to know my change in y values, in other words, how long is that vertical leg, well, I could just find my change of y values. And I could find my change of x values. Now, a lot of you are really used to slope, and you're tempted to do 4 divided by 4. And I can see why you want to do that, but that's not going to help us here. All that's going to tell us is that for example, 4 divided by 4 equals 1. What that tells us is that the slope of the line that goes through these 2 points is 1. That's the slope. I don't care about the slope right now. I don't even care about the equation of that line. I just want to know how long this specific line is. So, what I'm going to do is I'm just going to start calling this A. That's, like I said, that was this leg right here. And let's call the other 4 B. That was this leg right here. And let's go ahead and use the Pythagorean Theorem. So 4 squared plus 4 squared is going to equal C squared. That's this side right here. So that's going to give us 16 plus 16 equals C squared. So 32 equals C squared. And now to get C by itself, we need to take the square root of both sides. Well, I'm typing the square root of 32 in my calculator, and I'm getting a crazy decimal, so I'm going to write both answers. I'm going to say, hey, the distance is the square root of 32 which is about 5.66, it looks like. Okay? Now, let's head down to level 3. Oy vey. Well, I don't think this level 3 will be too tough, because we've done stuff that's very similar already. So what I mean by that is, why don't we do the same technique that we did up here? We can write these ordered pairs in a table, if you want to. Some of you already have a formula that you use. You use the distance formula, which is totally fine. I have no problem with that. But like I said before, if you're watching this video, I'm imagining you're struggling, so I'm trying to make things easier on you guys. I'm going to write these ordered pairs on the table. Find my change of y. In this example, that's -7. My change of x is -19. And just a reminder, if you don't know that, take 1 minus 8, and that will tell you -7. -10 minus 9, and that will give you -19. And, again, don't be tempted. We're not finding the slope of the line. If we were, we would do -7 divided by 19, but that's not what we're doing. We're going to call this variable a, and we're going to call this variable b. We're trying to figure out c, so let's use the Pythagorean Theorem. -19 squared. Notice I put that in parentheses. Anytime you're going to square a negative number, you've got to put it in parentheses, or else your calculator is going to give you a bad answer. Plus -7 squared is going to equal c squared. Oh my gosh, sorry. Is going to equal c squared. Now, in class it was probably pointed out that if I was looking for the distance between this y value and that y value, you can't really have a negative distance. So it is possible and okay to just write the number 7. I don't have any problem with that as long as you're careful when we go back to looking at slopes. So the -7, the negative part, doesn't matter when we're talking about lengths and distance, but it will matter when we go back to reviewing slope in preparation for the SAGE test. Oh man, I can tell I need my calculators. 19 squared is 361. -7 times -7 is +49. And that equals c squared. So let me take 361 plus 49, and I get 410, which equals c squared. And, I'm going to take the square root of both sides. And so my exact value is the square root of 410. My approximate value, square root of 410, it looks like that would be about a distance of 20.25 units away. Okay, so that was help on question 10. Good luck with question 13. I actually tried to give you a big hint here when I was talking about how your change in x and change of y could either be a +7 or a -7, because distance is actually just the absolute value of these numbers. Distance is always a positive number. Anyway, use that as your hint when you talk about this. I only need one answer here, but there are 2 possible answers, and I will give extra credit to people who figure that out. Alright, you guys, until next time, I will see you later. Make good choices. Do a good turn daily. Remember who you are and what you stand for. Okay, bye.